Okay, this second video is still going to use probability, but it's going to get a little more challenging. It won't be as easy as the previous problems, so take some good notes. Okay, a community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. The order which they perform is randomly selected during the show. Part A says, what is the probability that the musicians perform in alphabetical order by their last names? Okay, so we have 7 musicians, and if we're going to perform in alphabetical order, obviously the order matters because it's alphabetical. So you want to think about all the ways that you can get so what's the probability that you're going to get in alphabetical order? I'm just going to put probability of alpha. Well, there's only one way that's going to happen, right? If I line up 7 musicians, they're either going to be in alphabetical order or they're not. So it's going to be one out of all the ways I can order or arrange these 7 musicians. So you can do one of two things. You could do 7 factorial, which you recall is 7 times 6 times 5 all the way down to 1, or you could do 7p7 and permutations because order matters. And I have 7 musicians and I want to order all 7 of them. Well, 7p7 is the same as 7 factorial. And when you take 1 divided by 7 factorial on your calculator, which is maybe a little bit quicker, you get, 0.0002. So very unlikely that they're going to be in alphabetical order, which makes sense. Okay, part B says you're friends with 4 of the musicians. What is the probability that the first 2 performers are your friends? So you want the probability that first 2 are your friends. Okay, so how many ways can you get 2 of your 4 friends to perform first? Now think, does order matter? It does not. If you choose friend A and then B to perform first, or friend B and A, they're still going to perform first in the first 2, so it shouldn't matter. So this is going to be a combinations. So if I do 4 choose 2, that's going to be all the ways I can pick 2 of my friends out of the 4, how many ways I can arrange that to happen. So what is the probability that the first 2 performers are your friends? So 4 friends choose 2. And then my denominator, of course, is all the musicians, 7 of them, right, choose 2 because I want the first 2 performers. These pieces right here should always be the same if you have combinations in the numerator and the denominator anyway, because it would be how many you're choosing each time. This is specific to your friends, and this is specific to the total amount of things. And then you dump that on your calculator, and you get 0.2857, so a little more likely that that could happen. So again, with permutations, combinations, just think about, is there different ways this can happen? Is there different ways I can be alphabetically lined up? No, there's only one way. Is there different ways I can choose 2 friends if I have 4 to choose from? Yes. Does order matter? No. Did order matter here? Yes, I wanted it specific alphabetically. Okay, last question, and the card ones are usually a little more challenging. So the first one says, find the probability of choosing all diamonds when you draw 5 cards from a deck of cards. So I want all diamonds, which means I want 5 diamonds, right? In fact, I think I'll just write that because we're okay with the fact that we have a 5-card hand. So how many ways can you get 5 diamonds? Well, I could, let's see, how many diamonds do you have? So you have 13 of each suit. So I have 13 diamonds, and I want all the ways I can choose 5. Now, why combinations and not permutations? Well, if I have 3 of diamonds, 4 of diamonds, 5, 6, 7 of diamonds, would it matter if I switched around those 5 cards? No, I'd still have the same 5 diamonds. So combinations, any card question is combinations, by the way, because the order of the cards in your hand doesn't matter. It doesn't change the cards that you have. And then, of course, you divide by all the possibilities. Well, you have 52 cards, and how many 5-card hands can I get? And then you type that in your calculator. and you get 0.0005. So very unlikely that you're going to get all diamonds, which makes sense if you play cards. Now, you should be, by the way, typing these on your calculator and making sure you get this answer, because if you don't, we should go through that in class for sure. Okay, second question says, find the probability of choosing exactly 3 hearts when you draw 5 cards. So if I want 3 hearts, what does that tell you about the other 2 cards? That they're not hearts, I guess. So I'm going to say 2 not hearts. All right, so how many ways can I get 3 hearts? Well, how many hearts do you have? And again, you have 13 of every suit, right? So I could do 13 hearts, and I want all the ways I can get 3. And again, order doesn't matter. Because I want exactly, I'm going to multiply by how many cards are not hearts. So if I take 52 minus 13, that's supposed to be a minus, 52 minus 13, I get 39. So I know I have 39 non-hearts, and I want 2 of those. So again, I have 13 hearts, and I want 3. I have 39 non-hearts, and I want 2 of those. So this is going to get me my 5 cards. That should always add up to 5, right? And this is my hearts and my non-hearts. And then I divide by, again, how many ways can this happen? So 52, choose 5. And dump this on your calculator and see that you can get the answer. And I get 0.0815.